Ever wondered how you can watch cat videos from halfway across the world? It's all thanks to something called networking. This is the bedrock of our connected world. Without it, no emails, no streaming, no online games. We're going to break down these big ideas into small, easy pieces. You use the internet every single day, but what's happening behind the scenes? It's like a giant, invisible highway system. Data packets are the cars, zooming around at incredible speeds. They need to know where they're going and how to get there safely. This involves a bunch of rules and systems working together perfectly. Think of it as a massive team effort, but with computers and cables instead of people in tiny cars. In this article, we're going to demystify some of these core networking concepts. We'll talk about how your data gets packaged up, like sending a letter. We'll look at how your devices get unique addresses, just like houses on a street. And don't worry, we'll keep the super technical jargon to a minimum. So, let's get started on this journey to understand the invisible connections that power our digital lives. How does your computer send something like an email to another computer? It uses protocols. Think of the OSI model and the TCP IP model as instruction manuals for sending a digital birthday card. The OSI model has 7 layers, like 7 steps to prepare and send your card. The TCP IP model is more streamlined, often shown with 4 or 5 layers. Both describe the process. First, you have an idea, application layer. I want to send a birthday wish. Then you write the card and put it in a specific format, presentation layer. The postal service, transport layer like TCP, decides how to send it reliably, maybe with tracking. The physical layer is the actual mail truck, the roads, the airplanes, the physical stuff that carries your card. Every device connected to a network needs a unique identifier. This is where IP addresses come in. Think of an IP address like the mailing address for your house. It tells the internet exactly where to send information destined for your computer. Without IP addresses, data packets would be like lost mail. There are 2 main types of IP addresses, IPv4 and IPv6. IPv4 addresses are the older style, like 192.168.1101. IPv6 addresses are much longer and look more complicated, like 2010.db885.A3000000008A2, E03707334. Subnetting is like creating neighborhoods and streets within your own local network. It helps organize and manage devices more efficiently. Remembering long strings of numbers like IP addresses for every website you visit would be a nightmare. That's where the domain name system, or DNS, comes to the rescue. DNS is like the internet's giant super-fast phone book. You type in a human-friendly website name like www.google.com, and DNS servers quickly look up the corresponding IP address. When you connect your phone or laptop to a Wi-Fi network, how does it magically get an IP address? That's usually DHCP at work. Think of DHCP like the front desk at a hotel. When you check in, connect to the network, the DHCP server automatically assigns you an available room, an IP address. This automatic assignment is super convenient. Once your computer has an IP address and knows the IP address of the server it wants to reach, it needs a way to actually communicate. This is where protocols like HTTP, HTTPS, FTP, and SSH come in. HTTP, or Hypertext Transfer Protocol, is the foundation of data communication for the World Wide Web. HTTPS does the same job as HTTP, but it encrypts the communication between your browser and the web server. This is super important for things like online banking, shopping, or logging into your email. What if you need to transfer files, especially large ones, between computers? That's where FTP, or File Transfer Protocol, comes in. FTP is a straightforward way to upload or download files to and from a server. For secure file transfers, people often use SFTP, SSH File Transfer Protocol, or FTPS, FTP over SSL TLS. Finally, there's SSH, or Secure Shell. SSH creates a secure encrypted tunnel between your computer and a remote server. With all this data flying around, how do you protect your computer or your network from unwanted visitors? That's where firewalls and security groups come in. A firewall is a network security system that monitors and controls incoming and outgoing network traffic. Think of it like a bouncer at a club. Security groups are often used in cloud computing environments. They act as a virtual firewall for your servers. Now what if things aren't working right, or you just want to check if a server is online? That's where tools like Ping, Traceroute, and Netstat come in. Ping is like sending a quick text message saying, "Hey, are you there?" Traceroute maps out the entire journey your data takes to reach a destination. Netstat shows you all active network connections and listening ports on your local machine. This can help you see what programs are communicating over the network. So there you have it. We've journeyed from the basics of how data gets sent like a digital birthday card using the OSI or TCP IP models to understanding your computer's unique IP address. We've seen how DNS acts as the internet's phone book and how DHCP is like a helpful hotel clerk. We also touched upon the different languages computers use to talk for web browsing, HTTP and HTTPS, for moving files around, FTP, and for securely connecting to remote machines, SSH. And let's not forget the digital bouncers and guest lists, firewalls and security groups. Ultimately, all these complex-sounding terms and technologies boil down to one simple idea: smart, organized communication. Networking is all about establishing clear rules and efficient systems so that billions of devices can share information reliably and securely across the globe. If you found this helpful, give it a thumbs up. Don't forget to subscribe for more tech deep dives and explainers. Until then, stay curious and keep exploring.